So one of the things that the ideal gas law is really good for is actually calculating the molar mass of an unknown gas or of a gas. So I'll briefly explain to you how this works, and then we're going to do an example where we calculate the molar mass of an unknown. But this is how it works. You take a container and you evacuate it. Okay, that means you take all the air out of it, so there's nothing inside there. It's just a vacuum. And you weigh it. And then what you do is you fill it with a gas. So basically, in a container like the one that's shown on the right here, what you would do is you would put a tube on here, right, in here, along with a thermometer. That's what that's supposed to be. You evacuate all the air out of the container, and then you switch it to another line. So you have like a three-way valve. So one is to pull the air out, and then the other one is to put a new gas inside of here. And they probably do that a couple of times just to make sure you completely fill this container with the new gas. And then what they do is they weigh it again. And so now that is the mass of the flask with the vapor in it. Now there's other ways to do this, but that's kind of one of the ways, and it wouldn't necessarily be like a glass container. It'd probably be a steel container or something that can withstand the pressure difference. But they do that and they weigh it. And if you remember, right, the units for molar mass are grams per mole, right? So by subtracting these two, you have the mass of the gas that's inside of the container. So mass, m gas, right, is simply going to be 176.594 grams minus 175.0242 grams. And you subtract, and that's going to give you 1.5698 grams. So now all you need to do to figure out the molar mass is to figure out how many moles of gas you had. And think about what this information is. This is the volume, right? This is the temperature, and this is the pressure. So PV equals nRT. You can rearrange that so that N is equal to PV over RT. And then you can just divide the grams by the moles, and that'll be the molar mass. Now your book will probably show you an equation. Most textbooks do. It's really not worth remembering the equation if you can just remember grams per mole. And you know that grams comes from the difference in two masses, and moles comes from the ideal gas law. Okay, so we'll finish this problem, but let me explain to you how we're going to do this in the video lab, or in a lab if we actually ever do this one in the lab. Is the way it's done is you put a little bit of liquid in here, and you heat this till the liquid boils. And what will happen is the hot liquid will boil, and remember, at its boiling point, right, when it boils, its pressure will be 1 atmosphere. And so what you'll do is you'll allow this to completely evaporate, and what it'll do is it'll push all the air out of the container. Then what you do is you still have this container at some point, and it'll just be filled with gas vapor. So this is the vapor of the gas of the liquid, right? So you start with the liquid, you vaporize it, you push all the air out of the container, and then you cool the container again, and the liquid that filled the container will recondense. It'll recondense and it'll recondense, and when it does that, it will you'll be able to weigh it, right? So you just take the flask, you boil the liquid in it, and you push all the air out, and then you let it recondense, and then when you weigh it, it has the liquid back in the container that was the gas originally filling the container. So let's go ahead and do the calculation. I just pulled the data off the previous slide so I wouldn't have to remember, right? And so we're going to calculate the moles. In the moles, we need to go to 760 millimeters of mercury. We need the pressure in atmospheres again, right? That's going to be 0.83 2 atmospheres. And then the volume, it's in milliliters, so it needs to be in liters. So a milliliter is 10 to the minus third liters, and that comes out to 0.500. The decimal indicates 3 sig figs liters. And then the temperature, I just add 273.15 to it. That'll get me to Kelvin, and that'll be 368.15 Kelvin, like that. Now, you're going to plug that into the ideal gas law equation, so you have N is equal to, right, P times V over RT. And then when you do that, and I'm not going to fill it in, but I'll let you sort of do that part on your own, you're going to get 0.0138. 3 sig figs, let's see, 3807 moles of gas. And then using that, the idea that the molar mass is the mass, which was from the previous slide, 1.5698 grams, divided by the moles, right, 0.013807 moles, and we do the math, and we'll get about, let's see, hang on, 113.698. Now I've only got 3 sig figs, but that's in units of grams per mole, so we would call that about 114 grams per mole. And you'll notice that we're within one, right? One, like we're down to the ones place in terms of our precision. If you're a little more careful, you can actually get much more precise measurements of the molar mass. And so again, that's one of the useful applications of gas laws. It's a real easy way to figure out the number of moles. Mass is almost always fairly straightforward to measure because you just weigh stuff. And so we can calculate the molar mass of a number of different kinds of unknown gases.